Assalamu alaikum, dear students. Now I have one question for you. A-level mathematics P3, integration by substitution. You see this question, use the substitution, and substitution is given u is equal to 10x to show that this expression is equal to 1 over n plus 1. For the first part, you need some rules for substitution, and for second part and for third part you need to read this word. Almost in all questions he uses this word, hence or otherwise. So we should always use hence. Hence mean whatever you have proved, try your best to use that. Try your best to use that relationship, because that will save your time. So look, how do I do it? How I build the relationship between this expression and this expression, and then this expression and then this expression. That's what the most examiner wants from you. Let's begin. First I will prove that. Now look, u is equal to 10x. Now basically you need to express your whole expression in terms of u basically. This whole expression is in terms of x, and these limits are the values for x basically, for extremes. So now first of all, to transform this expression into terms of u, I need to differentiate. Why I need it? Because you also see dx is there. So du by dx is equal to secant square. Then dx is equal to du over secant square x. The derivative of secant square, trigonometric identity tells you secant square x is equal to 1 plus tan square x. And now du 1 plus u square, dx could be replaced by du over 1 plus u square. Now come to this question. When you see this is tan x, so you can replace this tan x by u, and it has power n plus 2. Same way for this you have u n, and then dx can be replaced by du over 1 plus u square. If you see, u raised n is common, so u raised n is common, and the leftover is u square plus 1, and then du 1 plus u square, you can cancel this with this one. Ultimately you get u n du, and when you integrate this you get n plus 1 over n plus 1. As you see, this is definite integral. Definite integral means upper limit and lower limit is specified, and these limits also needed to be converted in terms of u. Look, these are values of x as I told you, and now your expression is changed into u, so there must be the limits of u. How? U tan 1 over 4 pi, tan 1 over 4 pi is equal to 1. So you can also replace 1 over 4 pi by 0, 1 over 4 pi by 1, and so when u is 0, so lower limit 0, so 1 and 0. So feed these values in this expression, you will have 1 over n plus 1, your answer. So this way we prove these type of the questions by substitution. Now I will go to the next part of this question, where, as I told you, he told us hence or otherwise. The expression is secant 4x minus secant square x dx 1 over 4 pi and 0. Basically, you have this expression and you need to find the answer for it. As you see, the word hence is written there. Hence means, actually, when he uses the word hence, actually he is trying to give you the hint and he is expecting you that either you use it or you don't use it. This is basically deduction. If you want to use the relation of this part, you must transform this expression into this type. How do we do it? Look. This is secant 4x minus secant square x. And you see secant square x is common there and left over is secant square x minus 1. You know secant square x, and this is equal to tan square x. And once again, secant square, as I told you, is equal to secant square plus 1. Secant square is equal to 1 plus tan square and tan square x. And now this expression can be written tan 4x plus tan square x. Now basically, look, your expression has adopted this form. This is n plus 2 and this is n. And this is n plus 2 and this is n. This is 4 and this is 2. So you can directly relate this expression and this expression. When there was n, the answer was 1 over n plus 1. But now here you see there is 2, so the answer should be 1 over 2 plus 1. So this way you get your answer 1 over 3. So you no need to make substitutions and other steps of integration. So you can directly, first you will transform this expression into this form, and by converting this form into this form, you can directly use the result, and result is already proven in the first part. So I no need to do all these steps. After that, I have converted this expression into this form, and then I directly use this relation. Now same way I will go for the third part of this question. Third part of this question is
Good.
now you have this expression. And now once again you need to do this question with the help of this, because there is a word hence. Look, actually this is strange expression, but if you look it very carefully, you can express this whole expression, strange expression, into this form. if you could express this expression into this form, then you can easily use the result of this type of integral as you have proved here. Look how I do it. You saw the difference of power of first term and second term is 2. So you try, actually you need to split this in such a way that it should look like that. How I do it? Look, if I write tan 9x and then I by myself write tan 7x, but tan 7 raised x is already there. So instead of 5 tan 7, I can write 4 tan 7x. Now look, you have this form and this is exactly this form. Now again I write this 4 tan 5x and tan 5x, as you have split 5 tan 5x into 4 tan 5x plus tan 5x. So the next is tan 3x. Now you know this integral can be split into tan 9x, tan 7x plus, take 4 common from there, tan 7x, tan 5x, and then integral tan 5x, tan 3x. Look, as you already have seen, the answer of this would be 1 over 7 plus 1. This is the answer for this part. And the answer of this part would be 5 plus 1. And the answer of this part would be 1 plus 3. Because n is there. So the answer is 1 over n plus 1. So this way you get 1 over 8, 1 over 6, 1 over 4. So this is the easiest way, and you have used your first part's result in other parts of the question. So always try to use these type of strategy. These words are very important. Don't ignore. They gives you basically a hint. How do we need to perform the calculations. Thank you.